You yawn when someone near you yawns. You feel a strange compulsion to look down from a high place even though you have no intention of jumping. Your skin breaks out in goosebumps when you hear a piece of music that moves you, even though there is no cold and no threat. These things happen inside your body every week, and you have probably never once questioned them. Here is what almost nobody tells you. Despite more than a century of modern medicine, despite mapping the human genome and photographing individual neurons firing in real time, scientists still cannot fully explain several of the most common things your body does every single day. This is not a failure of science, it is a reminder of how much remains genuinely unknown about the machine you are living inside of right now. So let us walk through several of the most persistent and solved mysteries of human biology, phenomena your body performs constantly, that researchers have studied for decades, and that still do not have a complete, agreed-upon explanation. Start with contagious yawning. You already know yawning is linked to tiredness or boredom. What is far stranger is why yawning spreads from person to person. Studies have shown that simply watching someone else yawn, or even reading the word yawn, triggers a yawn in a significant percentage of people. Dr. Robert Provini, a behavioral neuroscientist at the University of Maryland who has spent decades studying yawning, found that this contagion effect appears as early as infancy and is observed across multiple species, including chimpanzees and dogs. The leading theory connects contagious yawning to empathy. Brain imaging research has shown that the same regions activated during empathic processing, particularly the posterior cingulate cortex and precuneus, also activate during contagious yawning. People who score higher on standard empathy assessments tend to yawn more readily in response to others, but this correlation does not amount to a mechanism. Nobody has identified precisely why an empathic brain state would produce an involuntary yawn reflex, or what evolutionary advantage that specific physical response would provide. The connection is documented. The reason remains unexplained. Now consider goosebumps triggered by emotion rather than cold. Piloerection, the technical term for goosebumps, has a clear evolutionary origin tied to temperature regulation. In animals with thick fur, the tiny muscles at the base of each hair follicle contract, raising the hair to trap a layer of insulating air. Humans retain this reflex even though our body hair is too sparse for it to meaningfully warm us. That part is well understood. What remains genuinely mysterious is why the exact same reflex fires during intense emotional experiences that have nothing to do with temperature, a swelling moment in a film, a piece of music reaching its peak, an unexpected act of kindness witnessed in a stranger. Research published in the journal Social Cognitive and Affective Neuroscience by Dr. Mitchell Culver and colleagues found that this emotional form of piloerection, often called Frisson, correlates with activity in brain regions associated with reward processing, including the nucleus accumbens. But why an ancient temperature regulation reflex would become wired to emotional peaks experienced exclusively by humans engaging with art, music, or social meaning remains an open question. Some researchers describe Frisson as a kind of evolutionary leftover circuit that got repurposed by more recently developed brain regions, but no study has definitively proven this. And the precise wiring connecting emotional intensity to this physical reflex has not been mapped. Now consider the placebo effect, one of the most studied and least fully understood phenomena in all of medicine. A placebo is, by definition, an inert substance or treatment with no active therapeutic ingredient. And yet, across thousands of clinical trials, placebos consistently produce measurable physiological changes: reduced pain, lowered blood pressure, altered immune markers, even visible changes on brain scans. Dr. Ted Kaptchuk at Harvard Medical School, who has spent his career studying the placebo effect, has documented cases where patients knowingly given a placebo and told explicitly that it contained no active medication, still experienced significant symptom improvement. Researchers have identified some contributing mechanisms. Expectation appears to trigger the release of endogenous opioids and dopamine in the brain, producing genuine neurochemical changes rather than simply a reported feeling of improvement. Brain imaging shows real activity changes in pain processing regions following placebo administration. But the deeper question of how a belief, with no biochemical substance behind it, reliably triggers specific and reproducible physiological cascades throughout the body remains unresolved. Nobody has produced a complete model explaining precisely how expectation converts into measurable biology. The effect is real, repeatedly replicated, and used as the control standard in nearly all of modern medicine. The full mechanism connecting thought to physiological change is still being pieced together. Now turn to the phenomenon researchers call the high place phenomenon. The urge some people feel to jump when standing at a significant height, despite having no desire to die. A study published in the Journal of Anxiety Disorders, led by Dr. Jennifer Hames at the University of Notre Dame, surveyed students and found that more than half who had experienced this urge had no history of suicidal ideation whatsoever. Hames and her colleagues proposed that the sensation may result from a kind of misfired warning signal. The theory suggests that your brain registers the height as dangerous and sends a generalized signal to move away from the edge. In some people, that warning signal gets misread by the conscious mind as an urge to jump, rather than correctly interpreted as an urge to step back. Essentially, a survival instinct and the cognitive system meant to interpret it momentarily fall out of sync. This remains a working hypothesis rather than a confirmed mechanism. Researchers do not yet know why some people experience this sensory miswiring and others never do, why it happens specifically at height rather than with other dangers, or what determines which individuals are susceptible. Finally, consider chills running down your spine in response to fear, awe, or anticipation distinct from the emotional goosebumps already discussed, but related. Researchers studying interoception, your brain's ability to sense the internal state of your own body, have found that the spine and the muscles surrounding it are unusually dense with nerve endings connected to the autonomic nervous system. Some researchers propose that a sudden chill represents the body's older threat detection systems firing in milliseconds, faster than conscious awareness can register the trigger. By the time you consciously notice the chill, the underlying neurological event that caused it has already happened and finished. This makes the chill, in a sense, a message arriving from a process you can never directly observe taking place. Why some experiences trigger this and not others of seemingly equal emotional intensity remains unclear. So what connects all of these phenomena? Each one involves a physical reflex with a clear evolutionary or physiological starting point that has since become entangled with something far more complex: empathy, art, belief, fear, anticipation. In every case, researchers can describe what is happening and even identify some of the brain regions and neurochemicals involved. But the precise mechanism connecting the ancient physical reflex to the modern psychological trigger has not been fully mapped in any of these cases. This is worth sitting with for a moment. You are not a fully understood machine, not by the people studying you professionally, and certainly not by yourself. Your body is performing extraordinarily sophisticated processes every single day that the most advanced scientific tools available still cannot completely explain. You yawn today, probably more than once, possibly because someone near you yawned first. Somewhere inside your nervous system, a chain of events occurred that researchers have documented but not fully understood. Your body has secrets even your own brain has not figured out yet.